Let's proceed to Otto cycle problem example. So first, let's read the problem. Otto cycle with compression ratio of 9.5. The air is at 100 kilopascal, 17 degrees Celsius and 600 centimeter cube volume prior to the compression stroke. Temperature at the end of isentropic expansion is 800 Kelvin. Solve for A and B problems. So for letter A, what is the thermal efficiency of the Otto cycle? We know that the equation for thermal efficiency is equals to 1 minus 1 over R sigma minus 1. So this R is the compression ratio and the sigma is the value of air. So we have, since in our problem, the compression ratio is 9.5, and then we all know that the value of air is 1.4, constant na siya. So solve these numbers, put it in your calculator, then you will get 0.594. Since it is efficiency, we should convert it into percent. So just multiply na nimo ang 0.594 sa 100. So makakuha ka 59.4%. And then for letter B, what is the highest temperature in the cycle? Since we know nga adiabatic expansion ang naa sa point C and D, so we will get the temperature volume relationship dito. So we have TC over TD is equals to the VD over VC to the power of sigma minus 1. We can represent using those temperature volume relationship. We have TC is equals to TD, temperature at point D times R sigma minus 1. So put the values together. Naasa atong problem kanina, ang temperature at TC or at point C is 800 Kelvin. 800 Kelvin times 9.5, which is the compression ratio, times to the power of 1.4 minus 1, we will get 1968.7 Kelvin. And then additional question, what is the difference between diesel cycle and Otto cycle? And because we know nga para sila under internal combustion engine, what is the difference between them? So let's find out. The operation is the same, but the difference is there is no fuel in the cylinder at the beginning of the compression stroke. So in our PV diagram, at point A, dito, ang i-compress lang niya is ang air. Ang pag-compress niya ato kay walay, walay fuel or gasoline or diesel. Dito na siya sa at point B. Diretso ignite na dayon siya. That would be all. Thank you.